Okay, today's topic is relative maximums and relative minimums, and absolute maximums and absolute minimums. Relative maximums are also sometimes known as local maximums. And absolute maximums and minimums are sometimes described as global maximums or minimums. A relative maximum is a point on a function that is higher than the points adjacent to it. A relative minimum is a point on the function that is lower than the points adjacent to it. A global maximum is a point that is higher than any other point in the range. An absolute maximum can be an end point for the function, or it can be somewhere in the middle. An absolute minimum is the value that is lower than every other point in the range. And again, that can be an end point for the function or a value in the middle. Okay, relative maximums and minimums give us more characteristics for describing our graphs of functions. So first, let's go back over domain. Domain, remember, goes from left to right. So in this graph, that would be from x equals -3 to x equals +3. And because we can see closed in circles, we would be able to use brackets. The range measures from the bottom to the top, and it measures the y values. In this graph, even though the y-axis is not labeled, I think we can assume based on similar scale that this would be -1. So the range goes from -1. And let's see, that looks like 1, 2 to a height of 2. The graph is touching at -1, so bracket. And there's a closed circle at +2, so bracket. Okay, intervals on which the function is increasing. There's two places where the graph is increasing. It's increasing from here at x equals -1, and it stops increasing at +1. Remember, intervals are parentheses. And then it begins increasing again here at +2 until the end of the domain, which is 3. For decreasing, it's decreasing from the beginning here at -3 until it hits -1. And then again from 1 to 2. Let's see. Make that a little bit neater. All right, let's see if we can clean up the graph here from the writings. These values won't erase. I can't figure out why. Okay, so now for the new topic, the relative minimum and the relative maximum. The relative minimum is the lowest point in its area. So one relative minimum would be here between the interval of decrease and the interval of increase. So at x equals -1, there is a relative minimum value of y equals -1. If I asked you when does the minimum occur, you would be able to tell me at x equals -1. And if I asked what is the minimum value, you'd be able to tell me that the y value is -1. That's not the only relative minimum though. There's a second one over here. That's the lowest point in its area. It's between the decreasing interval and the increasing interval. So there's another minimum, relative minimum, at x equals 2. When x equals 2, y equals 0. Okay, relative maximums. There's one relative maximum right here where the increasing interval switches into the decreasing interval. Again, if I asked you when the relative maximum occurred, you would say it's at x equals 1. If I ask you what is the maximum value, it would be y equals 1. Okay. These are the only relative minimums or relative maximums because the other values are endpoints, and endpoints can't be relative maximums or minimums. Okay, now for absolute maximum and absolute minimum. An absolute minimum happens at the lowest point in the entire graph, and that would be this point right here. Nothing is lower than the graph at -1. So at x equals -1, the graph has an absolute minimum value of y equals -1. And for absolute maximum, we can't get any higher than this point right here. So at x equals -3, y is equal to +2. So at -3, the maximum value occurs for the graph. Okay, another example, this one from the cubic family. The domain, since there's an arrow on the left and an arrow on the right, the domain would be -infinity to infinity. And the range from the bottom to the top would also be -infinity to +infinity. We can get more detail about the graph, though, by studying the intervals where the graph is increasing and the intervals where the graph is decreasing. So from the beginning, the graph is low and getting higher and higher and higher till right at this value. So we'll have one interval of increase. Then it's decreasing for a little bit, so we'll have an area of decrease. And then lastly, increasing again. Okay, so our interval where the graph is increasing goes from the arrow, so -infinity, until this value, which if the graph is counting by ones, which it is, then that would be about -2.5. Parentheses, because intervals are always open intervals. Okay, the next interval of increase would begin at x equals 0 and would continue indefinitely, so till infinity. Area of where the graph is decreasing. And again, the graph does not want to delete those marks. The interval in the middle here where the graph is decreasing, that goes from the x equals -2.5 and continues to x equals 0. All right, relative minimums, lowest points in the area. There's one here, and that's it. That value occurs at x equals 0. When x equals 0, the minimum of the graph is y equals negative, I believe it's counting by 0.5, so -1.5. Relative maximums, the highest point in their neighborhood. There's one right there. That's at x equals negative 2.5. And since we're counting by 0.5s and that's half a box, that would be positive 0.25. Absolute maximum, absolute minimum. Because this graph continues to infinity, it's impossible to give it a highest value or a lowest value. So this graph has no absolute minimum and no absolute maximum. All right, another example. This is what's known as a piecewise function. So the graph contains two pieces that we read together. Okay, so the domain on this, if we go from the left to the right of the whole shape, would be negative infinity to positive infinity because of the arrows. The range would go from the bottom, which is 0, to the top, which is the arrows. So 0 to infinity, and it's touching the 0, so we'd have a bracket for 0 and a parenthesis for the infinity. It's a very interesting graph, but when we look at minimums and maximums, there are not too many. This graph contains one minimum point. Since it's the lowest point in the area, it is a relative minimum. When x equals 0, the minimum occurs, and the minimum value is 0. And since that's the lowest point in the entire function, that also is the absolute minimum. This piecewise function does not contain any maximums. Some people may wonder why this open circle is not a maximum, but it's an endpoint, and an endpoint cannot be a relative maximum. And it's certainly not the absolute maximum because the arrows tell us that this will go to a positive infinity. So we would never be able to name a maximum value for having an absolute maximum. So this graph has no relative maximum and no absolute maximum.